provided on the lower left portion of the presentation screen, and then press the Submit button. You don't need to wait until the end of the presentation to begin submitting questions, so please send them in as you think of them. And if you wish to tweet during this presentation, please use the hashtag #SpeakSmartling, all one word. We encourage you to share your key takeaways from this presentation on Twitter. Again, the hashtag is #SpeakSmartling. That's SpeakSmartling. Now I'd like to introduce our speakers for today's webinar. Andrey joined Smartling after serving as VP of Technology at SpaFinder, where he developed and maintained the company's website and e-commerce platform in 6 different languages. Previously, he held executive positions at Runtime Technologies and consulted for JPMorgan Chase, where he was responsible for e-commerce, digital asset management, data warehousing, and other large-scale projects. He's a native Russian speaker. He holds a BS in computer science from Brooklyn College and lives in New Jersey with his wife and children. Brian Kelly is Vice President of Engineering for TimeTrade Systems, the leading provider of online appointment scheduling software. Brian has spent over 15 years building software for technology companies. He began his career with Iona Technologies in Ireland, and while there he led the development of a number of features within their distributed systems technology and later managed the international development of Iona's Orbix and Arctic integration products. After Iona's acquisition by Progress Software, he also managed the development of the Sonic C++ and .NET high-performance messaging and integration products. He lives in the Boston area and can always be found writing about software on morethancoding.com and on Twitter. So Andrey and Brian, take it over.
Thanks so much, Chris. Hi, this is Brian, and I'm going to start today with a poll. And just to get a feel for the audience and your interest in this particular topic, we'd like you to vote in this poll and tell us if you're currently faced with the challenge of having to internationalize software. So maybe you are, maybe you're in the middle of it, maybe you're planning. But if you could give us some hints as to your particular state in this area, that would be really great, so we could target what we're going to say towards your particular needs. So as you're doing that, I'll talk a little bit about what we're going to talk about today. We're going to introduce what we call the 10 Commandments of Building Global Software. And they're really to help you build software the right way so that it can be taken internationally later. And we have our poll results. So we have very big, 48% of people are faced with the challenge of having to globalize or internationalize their software. 20% aren't, but I'm sure that 20% may hit that at some point. And the remainder, 30%, are probably going to have to do it pretty soon. So that's great. So let's advance on, and we're going to get to the global challenge. So here's the question we're posing and we're going to answer. Is it possible to write software for your local market first, but do it in such a way that you make it easy to take it to a global market at a later stage? Now, if you are proponents of Agile or you're very big on Scrum, you're probably aware of concepts like YAGNI, Y-A-G-N-I, which stands for you ain't going to need it. And it's a very good philosophy to have when you're developing software. And what it means is you just develop for the story, for the specification at hand, and requirements for the future, you just don't implement them at that point. And what it means is you focus very carefully on the value of the thing you're meant to do, but you don't try and boil the ocean and solve every problem that really would extend the development cycle and make things take longer. And it's a great philosophy. The problem is it can lead to future issues when you're trying to adapt your software to localize it. And what we're going to talk about is ways to write software and not extend the cost or not make it inordinately more difficult, but prepare yourselves for a much easier and much less expensive internationalization project later. And they're very simple things. They're good to have in your code review process, and it really is it's common sense stuff. And the conventional wisdom across the software world is that internationalization is hard. In reality, it isn't that difficult, and as long as you take these particular pieces of advice into consideration during development. Speaking from my own personal and professional experience here at TimeTrade, a couple of years ago we saw demand for our software growing in international markets. Now, it started with English-speaking markets like Australia, the UK, and as a USA-based provider, that was pretty easy to do. But then, we got more interest from closer markets like Canada, which obviously has, there's bilingual speakers up there, and French is a consideration. And even within the USA, there's so many languages, and obviously Spanish is the biggest in terms of secondary languages. So our product started to get this demand, and since we're deployed into retailers like Best Buy, JCP, Sprint, etc., they have a global reach across the entire country, and the country contains people from around the globe. So we had to go through a pretty extensive internationalization project. As part of that, we discovered that there were plenty of things we could codify as kind of rules of the road that would make it much easier for us to adapt future developments and internationalize at a later stage. So we figured it all out, we wrote it up, I put it on a Huffington Post blog and publicized as much as I could, because I think it's a really important thing for software developers to be aware of. Because Andrey and I both believe that you don't have to make a huge investment in an upfront internationalization, even if you're not going to go global. You probably will if you're successful, and it doesn't increase the cost that much. So let's get right into it. So I'm going to hand it over to Andrey, who is going to bring you through the first rule, and that's on carefully managing your use of those little strings. Over to you, Andrey.
Thank you, Brian. So let's talk about basics. Let's talk about how you manage user-visible strings. So first of all, it's a typical, if you think of your typical MVC model, model view controller implementation, all of those things need to be kept separate. Your presentation in your application needs to be separate for a good reason. So very similar to that, the strings that are user-visible, they need to be separate from your code base. The reason for that is at some point you're going to want to send it to a translator one way or another, and if your code is if your strings are in your code integrated, translators are going to have a really hard time translating that. So you really need to keep it separate. And another thing that I see sometimes, the mistake that developers made is that they use those, let's say, property files in Java to not only put strings in there that are user visible, but also use those files for configuration settings. So this is not really a good idea because, at the end, all of this is going to get to a translator, and you really only want strings that are translatable in those files. Not only that, you need to make sure that whatever those strings are going to change. They're going to get translations. So you need to make sure that the strings can change and it's not going to affect negatively your application. So don't implement anything new. There is a number of formats that are supported by pretty much all of the translation management platforms. So if you're in Java, use property files and resource bundles. If you are working in .NET, ResX resources is a good idea. getText for C. iOS has Objective-C and string files that go with it. So every single translation management platform is going to recognize all of that, and there is absolutely no need to develop custom implementations. One of the frequent issues with localization is concatenation. So concatenation is actually very, very bad because you cannot have a good translation of concatenated strings. So an example here where you have a username in front of the text concatenated, what translator is going to see has logged in without the username. So In some languages, actually username, they would restructure the sentence, and username may appear in the middle, it may appear in the end, and translator would have no control over where username appears. A much better way is to actually specify a variable inside of your string, and translators, especially when they're using good translation tools, they would recognize this as a variable. They will not be able to actually do anything with it. The tool is going to preserve that variable being in, but at the same time, they would be in control to change the place where that variable is. Another sort of good practice is to include punctuation into your localizable string. So if you look at my example and sort of a second checkbox, in French, you actually require to use space before the exclamation point. And let's say if you include your exclamation point in your code base, but don't forget your space's actual string is going to be in there, translator really has, again, no control over over the space in there, cannot translate properly. So you're not going to get a good translation in your software if you do that. Another consideration here is especially when you go, not everything is left to right. There are right to left languages. We'll talk more in a little bit about this. So it's gonna create some problems there. So another thing to consider is the sorting may become an issue if you're sorting based on English. So an example here is Korea in Spanish starts with C, and if you sort this based on English, it's just not going to work great in a different language. Rule number 2, expect user-visible strings to grow and shrink. And I have some good examples for you. So read more in German is a lot longer. I think it's like 125% longer. Maybe I'm wrong, but it's somewhere in that range. And you need to make sure that, especially when you have tight spaces, let's say navigation on the website, when you don't have a lot of space, that may become an issue. Similarly, strings can shrink. Let's say in Chinese, you would use a lot less characters for some things comparing to English. And you need to expect that as well, and make sure that your application can handle sort of expanded strings or strings that are a lot shorter than what you see. So especially like website navigation, mobile applications where you have restricted space, this comes into play. So UI needs to adapt, and you need to make sure that you can handle longer and shorter strings. Rule number 3, remember the importance of context. So context is actually really, really important for translators. Think of the word home. Let's say you send a file to a translator, and all it has is word home that you need to get translated. So the translator has no idea whether you mean homepage or whether it's someone's house. In order to figure out and do the proper translation, they actually need to get back to project manager saying, hey, what is it? Like, how do I translate home? And the way to prevent this, this loops of going back and forth between project managers, developers trying to figure out where the string is and what it means, if you supply a screenshot, or if you supply an HTML snapshot with your string, it will clarify everything and make translation process a lot easier and a lot faster. So anything from screenshots, documentation, descriptions of what the string is, HTML snapshots, anything, the more you can include with the strings, the better the results are going to be, the translation results are going to be. So here's a screenshot of Smartling platform and how we do translations. So this is actually our site within our tool that translators use to translate. And you can see that the words in the middle of that image is highlighted, and this is exactly what's being translated. So when translators see this, first of all, they know where this is located and how to translate it, but not only that, they actually, when they type translation, it actually appears on the screen as they type it. So they could make a judgment call on whether the string is going to fit and either raise an issue or find a shorter translation right then and there, which would be perfect, for making sure that translations are not taking too much time. With rule number 4, back to Brian.
Thanks, Andrey. So rule number 4 came from an experience that we had, and I'm sure other companies have had it, but it bit us, and we'd like other people not to be bitten. And it's around graphics and images. So it's very common to have a SaaS tool on the web or embedded software, anywhere kind of software is hosted. It's very common to have embedded images, JPEGs, GIFs, you name it. If those images contain text or strings or anything at all like that, instead of being able to send a string in a file to a translator, you now have to sort of copy out the string yourself, send that, and then when you get it back from the translator, go and hire a graphic designer or designers and have them redo those graphics. With sizing and spacing, it can be a real challenge to change those graphics, and they might not fit. So it's much more expensive to do that. It's best to avoid it. Now, of course, for certain things like logos and things with important company branding, you might not do that. If your logo is going to be used across the whole sort of globe, then that's exempt from that. But for anything else in the product, just keep a watchful eye on that. And really, with the power of CSS3, if you're doing web-delivered software, it really can be done with CSS and rather than JPEGs or actual image files. All right, so moving on to rule number 5, which is about calendar differences. So TimeTrade, as an appointment solutions provider, we have a lot of experience in this area, put it that way. So when you say internationalization to most developers, they think of strings, they think of languages. But if you think about it a little deeper, you realize you're taking your product globally, and you're having to deal with a lot of different systems. And calendars are the first thing you'll encounter because times are so common in software to be displayed and modified. Time formats differ. In the U.S., we're very used to a 12-hour clock and PM or AM to denote morning or evening. But in Europe and most of the rest of the world, the 24-hour clock is used, and that drops those 2 or 4 letters for the PM or P.M. So the size is different, the system's just generally different. Date formats, of course, vary tremendously, and capitalization is different. I moved to the U.S. 14 years ago, and I was so used to the Irish model of day, month, year, and here it's month, day, year, and I wrote many a check with the wrong date on it and got bitten by that. So don't try and manipulate it yourself. You should use all the platform tools that are available to localize date formats from a canonical form, and we'll talk a little bit about that later. Also, don't rely on abbreviations, and this is kind of one of those insidious ones. You might have columns on a grid that denote days, and you might have M, T, W, etc. Well, that's just not going to work because they're indicating English, and then when you translate it into something like Spanish, it's not going to work because the M needs to be a lowercase l, not a capital M. And forgetting just about the representation, not everyone in the world takes weekend days the same as us. So Saturday and Sunday is very common here and in Europe, but it's not common elsewhere. Some people don't start their weeks on Sunday. They'll start them on Monday or Saturday or something else. And even more odd is that some countries don't even use a Gregorian calendar. If you've ever been to Sweden, you might hear people talk about the Vecka system, where instead of talking about months, they talk about the number of the week in the year. So, I'll see you sometime around 48, which would be the 48th week of the year. Now, of course, heavily related to calendars are time zones, and they're close to our heart at TimeTrade, of course. And the big thing that surprises most people is that there are not 24 time zones, there are hundreds. If you look in the time zone database, which is the most popular computational representation of time zones, you'll find hundreds of them. I think it's around 450. The reason there's so many, well, it's politics usually. Geographies and countries adapt different time zones based on people voting a certain way to change it, countries being overtaken by others, et cetera, and adapting them in. It's changing all the time, and even in recent history, they've changed. So when you're computing times to render to the user, you not only have to take care of what locale they're in, but also what time does it refer to. So if you're saying, 2:30 p.m., if you're talking about 2:30 p.m. in general, you just localize to that time zone. But if you're talking about 2:30 p.m. 100 years ago, you might not be talking about 2:30. You might be talking about 1:30 because of a difference. Maybe they didn't observe daylight saving time 100 years ago in that particular region. Now, some zones have partial hour offsets, and I mention this because a lot of people don't realize that there are some zones that have partial hour offsets, and they build graphical calendars or representations of time that assume everything is on a nice hour boundary. If you're going to bring a product to Canada, you better not do that because Newfoundland is 3.5 hours from GMT. Nepal has a 15-minute offset from the boundary, and Iran also has 3 hours 30 minutes in the other direction. So these all, you cannot assume that kind of nice add 1 hour, add 2 hours, or add n hours to your UTC time. You've got to make sure you can handle partial hours too. So I've mentioned UTC, and if you do anything with time, you're probably familiar with it, but it is the thing to use when you're storing a time zone, or a timestamp, because you absolutely you should always normalize to that format and then render based on what the user expects to see in their region. And don't reinvent the wheel. There's plenty of good standards out there. We're going to cover them in a little bit for time representation. Things like JOTA. If you've ever done any work in Java with times, then you've probably heard of JOTA. But the original version of Java came out with a criminally bad date-time manipulation library, and it was up to the community to contribute a third-party library, and it was very well done. And JOTA actually now has been improved further and is now in Java 8 as part of the standard java.time package. There's an equivalent to JOTA in .NET called NOTA, and there's plenty of things in iOS and Cocoa like NSDate, NSCalendar. And if you're doing things on the web, Moment.js is a nice library for that. And other frameworks like Dojo have their own calendar, date manipulation, time zone stuff in there as well. It seems like something that is tempting to do yourself, but don't. The libraries here are very extensive and take care of all of the very different vagaries and weirdness of different time zones. And believe me, you do not want to get it wrong because, and this is something, like I said, in TimeTrade we have to do. If we have an appointment booked for somebody and we don't care for daylight saving time, then that appointment's going to be missed or somebody will arrive late. So it can have a real business impact. It's not something to dismiss as, oh yeah, no big deal. It can be a real big deal. So now we've talked about these different dimensions. Now let's get down to brass tacks about how you would store things and get into the representation. So there are plenty of data standards about these kinds of concepts, and you should use all of them. It's really important to stand on the shoulders of giants because people have thought about these things for probably much longer than any of us. And those standards, not only have they been thought through, but they're also available in tools. They're understood by translators, or they're understood by your development IDE or whatnot. So just always look for an established standard when you're looking to do something like this. And the best example I give is for international phone numbers. A lot of people don't know there's a standard for that. It's called E.164. And there's an example here. It's +1, and the plus denotes an international number. The 1 is the country code, 617 is Boston, and 555 is the movie version of a phone number. But that's the format you should store if you're going to have any kind of interchange with tools that need to manipulate phone numbers, and also just it's good practice to normalize and have a standard when you're storing your data. For timestamps, 8601 is ISO 8601 is probably familiar to a lot of you, and it's definitely the thing that you should use. There's different renderings of it. Most people gravitate to this particular kind of format, which is the full Zulu time. And Zulu time is essentially the same thing as UTC, which is also very similar to GMT. So that Z at the end denotes Zulu time. And it's a very precise format. It can also be more granular. You can get down to milliseconds and whatnot. So definitely leverage this standard if you're doing anything with timestamps. If you're storing language codes, and this is very important if you're going to localize your software, don't make up your own system for languages. Use ISO 639. An example there is ZH for Chinese. For country codes, similarly, ISO 3166 has the full set of those. Now, if you do any kind of web development, you probably recognize these as things you'd see in the accept language header in HTTP traffic. And if you look at the HTTP specs, they reference these ISO specs saying when some browser passes a request to say, I would like to accept this kind of language for this kind of region, it comes, the selections come from these standards. So again, stand on the shoulders of giants and use what's provided. Finally, for time zones, there's a famous database called the Olson database. Officially, it's called a TZ database. And it's named after the gentleman who maintained it for many years. He recently retired, actually. And that denotes databases, denotes time zones, not just in current use, but also has historical data. So the problem I mentioned earlier about knowing what a time should be rendered as if the time actually refers to something, decades in the past. That's all in there. It's very comprehensive. It's well integrated. It's available in most development SDKs and libraries, and certainly something that you should use. If you've ever seen the difference, in, certainly old versions of Microsoft Windows did not use it and had their own time zone database, and it caused all kinds of issues with trying to figure out what was what. So I'm going to hand it back to Andrey now, and he's going to bring you through Unicode.
Thank you, Brian. Okay, so let's talk about encodings, ASCII, Unicode, and so forth. So first of all, obviously avoid ASCII codes and use Unicode as much as possible. So remember the days of when we've been doing various bit flip tricks for different characters? Those are long, long gone. I don't think anyone is doing it nowadays. So Unicode is here to stay. It's been around for a long time. So one of the frequent problems is that with Unicode is that it's either not used consistently throughout your application or throughout your infrastructure. So as you're switching to Unicode or as you use it, it's very important to make sure that all of your applications, all of your libraries, all of your vendors, third-party vendors actually support it properly so that it works consistently throughout the application. So there are multiple flavors of UTF, right? There are UTF-8, UTF-16, UTF-32. What are the differences? So UTF-8 was actually a brilliant invention. UTF-8 supports characters from 1 to 4 byte sizes. The reason that it was done is to be able to support most of the ASCII codes the way that people used them before in UTF-8. So the slower part of UTF-8 is actually quite compatible with ASCII, and you could swap ASCII out with UTF-8 fairly uneventfully. When we go to UTF-16, UTF-16 is 2 to 4 bytes, and UTF-32 is 4 bytes, 4 bytes only. What Apple recommends right now, as an example, is they recommend to use UTF-16, but they would actually support any flavor of UTF. So if you have an enclosed, kind of an enclosed ecosystem like Apple, you could actually switch to UTF-16 and it would be totally okay. So database. Databases are tricky, especially when you're talking about legacy databases that you had for some time that you need to support. You need to remember that one character, not necessarily one byte, and not necessarily corresponds to the sizing the way that to the column sizing the way that you think it would. And then you need to use Unicode compatible DB types for user visible strings. So for example, UTF-8 MB4, and a lot of people are actually making a mistake of using UTF-8. It works perfectly at first, and then at some point you realize that it doesn't support certain parts. It's Unicode extension codes, and it's actually very painful to switch. This is one of the mistakes that we made at some point, is we used UTF-8 instead of UTF-8 MB4 with MySQL. So just be careful with the databases. Rule number 9, assume text may flow from right to left. There are a bunch of languages out there, Arabic, Hebrew, Persian, and so forth. They all flow from right to left. So what do you do with this? Especially what do you do with this when you have quotes inside of your, let's say, English quote inside of your Arabic text, or you have embedded numerals. Like, what do you do with that? So in a lot of cases, actually, browser is going to be very helpful, and it's going to recognize the language that you're using from the encoding that you use, and actually attempt to flow it properly. But you need to be very, very careful with that. Different browsers may behave differently. When building web applications, it's a good idea to change the direction and see what happens for the entire document. But changing the direction alone is not going to do it, because what you need to have is you need to have pretty much mirror copy to do it right, mirror copy of your application, of your website. So with the website specifically, there are libraries that will help you with this. And what they do is they process so when you do your build, they go in and they process your CSS, and they create a copy of your CSS flipped, mirror flipped. So when you have right, they're going to put left. When you have left, they're going to put right, and so forth. And they're doing it very intelligently. So one of those libraries are two that you can check out if you are interested in this topic. And they actually work surprisingly well for the websites. Okay, rule number 10, back to Brian.
Thanks, Andrey. So if there's one lesson you should take away from this, it's this one. And especially for the people who are facing but haven't yet started an internationalization project, or people who are just beginning. This can really bring the most value and cost savings. Even if you're halfway through or getting towards the end, it's still something good to bring into your test suite. So the concept is called pseudo-internationalization. And what it does is it tells you whether or not your application is international capable, but without the overhead and the cost of actually internationalizing it. So if you have any plan at all, or if you think there's any inkling of a global rollout of your application, this is something good to check. It's just as important in my mind as making sure your builds don't have warnings or general cleanliness and code reviews and indentation and anything else that engineers do as part of just being professionals. At this stage in the way software gets used, it's unprofessional to consider a global reach, because it's going to be such a burden to people who have to do it, or people who have to use your software when it's not translated. So let's talk about how you do it. It is a very simple trick, essentially, but it's a trick with a lot of power. If you have English-speaking engineers, and they're typically testing with English strings, as you'd expect, all you do is add on some foreign characters from different non-English scripts. Like, let's say here, you can use an Asian script, you could use something. I would avoid things like Cyrillic that might be an extended ASCII or ISO 88591. Definitely go for the more kind of foreign scripts, and definitely Asian scripts like Chinese or Japanese would push the boundaries as much as possible. So crucially, the engineer or the QA person doesn't have to understand that other language. What they are going to do is, by using it for any transaction or any test, they're going to verify that end-to-end, that international set of characters can go in through your web app or your API into your database, back out all the way, and every tier of your system and every function is passing data correctly, negotiating the right content type, understanding Unicode, etc. But the best part is you don't have to invest in an enormous internationalization project. You don't even have to get professional translators engaged or pay anything extra. It's just another couple of tests. It's definitely something you could do at the unit test level as well as at the functional test or integration tests to test your entire product. And here's an illustration of how it works. And we did this at TimeTrade. This concept of pseudo-internationalization has been floating around for a little while. We didn't invent it, but it makes so much sense that it's just got great value. So on the web browser, the transaction in our application occurs. In our case, somebody's booking an appointment. And it's John Doe, but it's John Doe with these characters from the Unicode set applied at the end. The reason you use both English and non-English characters is that you still need the engineer to correlate back and have some easy way to read, oh yes, it's the John string. Because when things fail, they typically fail with question marks. That's usually how character encoding problems end up getting rendered. So if you've all question marks, it's really hard to trace down, well, I don't know what string I'm looking at. So what typically happens when there's a fault, and we encountered this and we fixed it, in this example, the fault occurs in the app server. So things are going great. They go over from the web browser to the web server, to the app server, into the database. They were stored in multi-byte format, and then retrieved from the app server in our read transaction to pull it back out. And then, just all of a sudden, the international Asian characters changed to question marks. So now, not only do we know that there's a break, but we can follow the breadcrumb trail and easily determine where the break was. And this brings huge value. It's one of those 80-20 things. You don't have to do much work, but you can constantly run in your automated test suite a verification that your product has, at a basic level, but a very valuable level, it has international capabilities. So those are the 10 commandments, and we understand there's probably a lot of questions. So I think we'd like to hear from you guys.
Yeah, great. Thanks, Andrey and Brian. There are some great questions that have come up. So here's the first one. How do you prefer to store dates in MySQL so that it is easy to port between different time zones? Would you use a timestamp or Unix time or some other date, month, year format?
Okay, I can take that because I have a lot of experience with this. And for people who don't know the differences here, Unix time is measured in milliseconds since what's called the epoch. It is, let's see, midnight on January 1st, 1970 or something like that. I don't like to store things in Unix time purely because the de facto standard now and the more common is ISO 8601 storing a UTC time. So if it's a timestamp, it's absolutely 8601 format and using that Z at the end to denote Zulu time. Okay.
Great. Thank you very much. Next question. How much do translators charge?
So this is Andrey. I'm going to take that. So when we take a look at the industry, first of all, what we need to understand is that translations is typically a workflow. So you can just translate, you can translate and edit, or you can translate, edit, or view. Those are sort of three typical workflows being used. And the workflow you pick depends on, how much quality do you want to have in there? If it's absolutely critical text and you really want to have high quality, 2 or 3 step translation is typically used. When you're trying to sort of save a little bit of money and quality is not, it's important, but it's not like really, really important, then you could just go with the professional translation. So if we look at the actual costs of professional translation, what you would likely see is that it starts anywhere from like 10, 11 cents and goes up to, I would say, 30, 35 cents for highly specialized scientific content that is actually fairly difficult to translate, and you need highly specialized translators. So that's the answer.
Great, thank you. Yeah, okay, so here's a follow-up question. How do I send strings to translators for them to work on? Would it be an Excel file, Word doc, CSV, XML, or something else?
So this is Andrey again. I'll take the question. It depends on the translation platform that you are working with. If we take a look at Smartling translation platform, we would accept pretty much any of those files. It depends on what's more convenient for you. And we're highly configurable in terms of how do we process CSV, how do we process XML and JSON. You could actually specify specific details of the structure, the items that you want to translate in the file that you're sending us. Now, having said that, again, just what's going to be helpful for you is to use common formats, nothing too custom. Otherwise, a lot of translation management platforms are not going to be able to process that. Chris, back to you.
Okay, thank you. So, so here's another follow-up question to go along with that. So isn't this problem much less important now that users have Google Translate available to them?
Ryan, do you want to tackle this one, or do you want me to?
I can certainly tackle it. There's been such great advances in machine translation, and Google Translate is a very popular example. But it does really, it's nowhere close to what a human translator can do. It has great statistical knowledge, but there's such a sort of gap or chasm between what Google Translate and other machine translation tools can do compared to a human. For example, cultural context, cultural awareness, context of the application. It's good for if you're just going to go to a web page and have a peek and try and get a sense of what some document is saying in another language. But for professionally developed software, it just doesn't work. And maybe it will someday, but right now it's not there.
Very good. Thanks for that answer. Next question is, how do you detect the time zone on the client side? Can you depend on the client machine? And what happens if the client time setting is wrong?
I'll take that because that's a really good question. So there's differences in how to solve it based on if you're a browser, web application, or whether you're a native application like running on a phone or on a laptop. The likelihood of the time setting being wrong is minimal in most mobile devices because of GPS and the recognition of the mobile device. Oh, I'm in a time zone. I just drove through Indiana, so I got to change my time zone 17 times or whatever, how many crazy time zones Indiana has. In a web application, it's really difficult, and here's why. There is no HTML standard or browser JavaScript API that's standard that returns a definitive time zone. In other words, the browser cannot reach into the operating system and say, please tell me the time zone I'm in. What it can do is it can reverse engineer the time zone through a bizarre amount of time zone computations. You set a timestamp and you say, please render this in this particular way, and then you look, oh, it moved it ahead 5 hours, so I think I'm in this country, and it also applied saving time, so I think I'm in this area. And there are libraries, and they have, they're not rolled into any browser standard, but they can be downloaded. They're just simple JavaScript libraries. They do a good job. But here's the cautionary tale. A lot of countries share the same time zone, and it can be a user frustration to detect the wrong one. So if I detect Central European time, I don't know if that person's in France, Germany, anywhere like that. That's maybe okay, but there are plenty of areas where there's a lot of tension. If you try and detect a Middle Eastern time zone, I mean, Israel and Palestine have extremely similar time zones, but they are actually very slightly different. You don't want to present the user the wrong one and frustrate them there. So in a browser, you've got to go look at third-party libraries in order to get the Olsen time zone. If it's on the client machine, I think you should always trust what's set because there's not much you can do. If it's wrong, there's not much else you can. You just have to assume that the client machine has the correct time zone set.
All right, very good. Thank you. Next question. Are there any open source automated tools for translation testing?
So this is Andrey. I'm going to take that. Let me put it this way. I really don't know anything out there that is really good. There are some open source packages that are somewhat outdated that you may be able to use for this, but they cannot compare to what we have right now commercially.
Great, thank you. Okay. Let's move on to the next question. What kind of interface we have between software quality managers and translators in agile development?
So let me take that as well. This is Andrey. So one of the trends we see in successful companies that embrace when they go global, they embrace it. They take it very, very seriously, not just by their localization department, but by everyone in the company. And we see it, again and again. If a company truly embraces it, they're successful with their localization efforts. So what does it mean for agile development? So again, the successful practices that we saw is that every iteration, there is someone in the team on stand-ups. They have the point of view of localization. They take the point of view of localization, and they're required to sort of bring it up and make sure that everyone is aware that in this iteration, the following things need to happen from a standpoint of localization. So this is probably the best way to do it. And then the interface between the managers who sort of localization managers and software managers, I'm probably going to say an obvious thing, but they have to work well together, and they have to listen to each other sort of best practices and how to do it better and improve with time. So I hope this answers the question.
Very good. Thank you for that one. Here's a very timely question since this past Sunday most of us went through this, but any comments on how to handle the transition to and from daylight savings time?
I'll be happy to take that. Google the address of your local political representative and badger them until they remove this ridiculous concept from our world. As engineers, this is just one of the most annoying things. It's not impossible to deal with, but it's just really annoying. In order to handle it, there's two ways you can transition to it. One of them is just rendering time and just knowing that saving time is in effect. That's easily handled by libraries who are aware of the time zone you're dealing with, and you literally just say, please just localize this time, and then they take the UTC time you have and then correctly render it as 11:30 or 10:30, depending on if it's in effect. The more difficult transition is if you've got an embedded system or a running system that has work to do at 2 a.m. on the Saturday night when it's actually occurring. And typically, you can see it done a variety of different ways, but you've just got to have a special handler for that is either watching for clock changes that are out of the ordinary. If you're using the system clock to do things, you have to build in awareness of this, because if your code isn't able to handle a quick jump forward by an hour or a jump back, it's going to probably break. Or if you're the one responsible for changing the clock, it's a special case. You just have to build all that logic in yourself. There might be libraries out there, I'm not sure, but definitely a political solution is better than a technical one.
Great. Thank you for that. Next question is, what is the recommendation for variables in a translation string?
So I'll take that question. The recommendation is just to be consistent. Use the consistent way and try to stay with the technology, with the defaults that technology provides you as a standard for this. So this way the variable is going to be properly recognized. And what translation management platforms do, and we've paid really a lot of attention to this, is translators are not going to be familiar with technology. So we do everything that we can to actually protect that variable and to make sure that it stays as is in a translated string, and we give developer hints of what can be in that variable potentially, so that they could properly position it within the translation. It's very, very critical that translation tools do recognize those variables and handle them properly, because translators just not very good with the technologies that we use. So I think that's pretty much it. One other thing I'm going to say, that we've specifically designed capabilities to provide a way for us to detect non-standard variables. So if you do have non-standard variables in your files, you could actually instruct our platform to look for them and to recognize them properly as variables.
Okay, very good. Thank you. Next question is, can you please list some useful libraries, either open source or commercial?
I can start that, and maybe Andrey might want to add. I was referring earlier to a time zone detection library in JavaScript. It's called JS Time Zone Detect. It's available on Bitbucket. And if you just Google for that, you'll find it. Certainly, for these, I don't know if the question is specifically about time zones or languages, but all of the ones we mentioned throughout the presentation are absolutely core. What I would do is, rather than try and have an authoritative list here, recommend that for whatever platform you're working on, look at the vendor's documentation or look at the most popular commercial supported version of it. So if you're a Linux developer, look at Red Hat and see what they offer. They probably gravitate to the best, most sort of solid library. And I think that's basically it. It's go research and make sure you pick one that has the most adoption, because that will make your job a lot easier. Andrey, do you have any other suggestions for libraries that people should look at?
So not really, not besides the one that was listed in the presentation. But what I want to say, if you're looking for something in particular, just drop us a note at hi@smartling.com and reference this webinar, and we'll, if we know the answer, we'll help you with the right library.
Great, thanks, guys. Next question is, how do you handle different punctuation marks in different languages like Hindi?
So I'll take that. I think the most important thing here, as I mentioned in the presentation, is to include everything into the string that translator can properly translate. And from that point on, it's up to translator to provide a correct translation according to all the rules of the particular language that we're translating to.
Okay, good. Thank you. Next question is, which language translator do you prefer?
Well, I'm not sure if that refers to an individual human translator or maybe a translation service. I think, rather than endorse our particular ones, I think that's just a task you have to go through as part of your translation project is find ones that you think are competitive, have good quality, and all the things you'd expect from any kind of third party.
Okay, very good. And looking for some more questions. A question did come up about the presentation slides. Yes, they will be available to everyone. So hopefully that answers your questions on that one. There's another question about being able to view this presentation in the future. Yes, it will be. This is being recorded and it will be available for everyone to listen to, as well as those that could not attend today. So that's hopefully that answers that question. And then there's one more question looks like that could be asked, and that is, could you please repeat or explain why ASCII is not good?
Because ASCII cannot handle the world's languages. And if you're planning to take your product beyond, I think it's 10 or 12 languages that ASCII can support, like French, English, and a couple of languages like that, then don't bother. I mean, the world moved on from ASCII many years ago when it established Unicode, and that is absolutely the code set to use, the encoding to use. ASCII is just too limiting for anything that's going to be user visible.
Right, and I'm going to add to that. ASCII is 1 byte only, so it does not fit all the languages. And throughout the history, people were very creative by creating 1 byte encodings based on ASCII to represent certain symbols. So if you go to browser encodings menu, you would see a bunch of those actually in different languages. But I'm really, really glad that we went beyond that into Unicode, because it was impossible to support all of those different encodings.
Mm-hmm. Okay, very good. It looks like we have time for one last question. We're approaching the top of the hour. So the last question we're going to ask is, how do you recommend to store and process currency?
That's a good one. Well, currency is not something that is transferred across. If you do, you probably have some auditors asking, hang on, you just changed this euro sign to the dollar sign. You can't just do that. I think the question is probably more about data formats and how to store it. Floating point is a very bad choice for most financial transactions, just because of the different renderings. There's a really excellent paper out there on why floating point has to be treated with extreme care. So you can use, there's decimal types in most languages, and certainly just avoid the challenges with floating points when you're dealing with currency. So you would typically store it as a decimal number, some kind of number that you can have a decimal point in there, and also separately store the currency format. I'm not aware of a standard for currencies, on the same style as the ISO standards for country codes. There may well be one, and I would encourage the person who asked to go and just do a quick search. Very likely, given things like SWIFT in the world and these international financial transaction standards, that there is a standard for euros have this code or dollars have this code. Maybe it's the USD EU ROR encoding. I don't know. So whatever is the de facto or official standard should be used, and store that separately to the actual decimal amount. There's no UTC version of this. If you think of it like this, there's no normalized currency format. You have to store the local currency value each time.
Great. Well, thank you very much, Andrey and Brian. Looks like we've answered all our questions, and we've run out of time. So I'd like to thank Andrey and Brian for a very informative presentation. Special thanks to everybody for taking time today to attend and participate. And on behalf of the IEEE Computer Society and Smartling, thanks for attending, and have a great day, everyone.